Welcome to the introduction of FireCAD. FireCAD is a powerful all-in-one system design tool powered by AutoCAD OEM. FireCAD streamlines the production of fire alarm layout drawings by using an extensive parts database, automating battery and circuit calculation reports, and generating a system riser diagram easily and efficiently. This results in lower design labor costs and consistent accuracy in plan submittals. FireCAD was designed for ease of use by leveraging an industry-standard platform that most professionals are already using. A working knowledge of AutoCAD basics is recommended, and current AutoCAD users will feel right at home. Existing drawing templates, block definitions, details, and DWG format drawings can all be utilized directly within FireCAD. Please enjoy this quick demonstration of FireCAD producing a small office design. To get started with FireCAD, the typical process requires an architectural background drawing. This can be an existing DWG format file or can be imported from a PDF vector. In this demo, I'll create a new drawing and import a PDF file. The new drawing file was created using an existing template which has multiple D-size sheets and title blocks already set up to save time. To import the PDF background, I'm using the PDF import command. I've selected a vector PDF file for the best results. After setting some options for the PDF import command, I'll click OK. Next, I'll pick a location in model space where I'd like to place the imported floor plan. With the floor plan placed in the drawing, I can finally save it into my project folder. Next, I need to create a FireCAD project file in my project folder. The project file contains parts and circuit properties of the devices and also links to the working drawings that I'll be placing devices on. The project creation wizard requires a project name and a selection of project templates. These are organized by manufacturer. The project file must be placed in the same directory as the working drawing backgrounds. The database connection can be selected to choose a local offline copy of the database or the cloud-based connection provided with FireCAD. I'll select the manufacturers I want to use for the equipment in this project. I'll also select generic, which contains various contact devices and junction boxes. My project is created. Now I'll link the drawing I want to place and connect my devices on. The FireCAD palette, docked on the left of the screen, now displays the current drawing linked to the project file. I'll click the Save Project button and then move on to placing devices. To place devices, FireCAD provides a device palette. This is similar to a content library and contains all the parts loaded into the project file. After selecting the Device Palette tab, I'll search for the device I'm looking for by typing the part number in the filter box. Now I can easily see all parts in the list that match my filter, and I'll select the device I'm looking for. After selecting the device, I'm prompted to select a placement for each one. In this case, I'm overlaying the new wall mount horn strobes over the location specified in the background. After placing the wall mount horn strobes, I'm prompted to choose the candela setting for the devices I just placed. This can be set later on, but I'll start out by making an initial choice. I'll continue the placement process for each part and then decide what control equipment to use. Checking device coverage is a good idea at this point. I'll select all the horn strobes and turn on device coverage to see if my candela settings are correct. With the transparent hatches that are dynamically displayed with each device, it's easy to see where I can make adjustments in my layout. It looks like I missed a couple of rooms, so I'll be sure to add the missing devices and place the control equipment. When placing panels or modules with circuits defined, an option to set a name appears. This is helpful when determining which circuit is connected to a device, especially as more panels are added to the project. Now it's time to start connecting the devices to circuits that are predefined on the panel I'm using. First, I'll select the Circuits tab on the palette. Then I'll select the circuit I want to work with. To start connecting, I'll click the Connect button. This will show a green highlight on each device that is compatible and ready to connect to this circuit. I'm selecting the devices in the same order that they would be connected in the field by the installer. This will allow the most realistic calculations and wire labeling. After the connections are complete, expanding the Circuits Palette tab shows all calculation and limit data in real time. In addition, the connection length between each device is listed and can be edited here. All connected devices show a unique formatable label that clearly identifies a source and an address. I'll continue this process with the NAC circuits as well. After connecting the NAC circuits, I'll make sure that the voltage drop calculations and the total circuit current are above the minimum values for the application. Now that all circuits are assigned, I can manually or automatically draw a wire path that represents the circuits I have connected. In addition, I can automatically generate wire and conduit fill labels. All circuit wire paths have been drawn following my connection sequence and placed on separate layers. Labels have also been added. I can manually adjust the layout or leave it as is. Now that the system layout has been completed, I can generate the automatic reports and riser diagram. I've generated the device legend first and placed it where I want it to be in model space. For this project, I'll also add a cable and wire legend, point-to-point voltage drop calculations, an addressable device schedule, and finally a battery calculation report, all with just a few clicks. I've now placed all reports in an area aligned with the paperspace viewport. The last item I'll generate will be the system riser diagram. With the most time-consuming tasks complete in just a few minutes, I can take more time to add details, double-check all values, and publish the finished drawing. The published command is an easy way to produce a high-quality PDF with all sheets that can be used for electronic submittals or sent to a printer. The new PDF file is generated and contains all selected sheets plotted to scale and ready for review. This concludes the short demonstration of FireCAD. Thanks for watching.